Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see question number 7. In question number 7 students, you have to explain the thermal equilibrium diagram. Explain the thermal equilibrium diagrams of mixture of giving solid solution. So students, if you are getting solid solutions, we have to explain the properties on the basis of thermal equilibrium diagram. Now students, what is thermal equilibrium diagram? For that students, first we will see you have to write the answer like this: thermal analysis. With the help of the heat, we are going to analyze the alloys. Thermal analysis is very useful in explaining the structure of alloys. We want to explain the structure of alloys. Thermal analysis is very important students, which related to study of other properties of alloys. So we can study the other properties of alloys. Okay students, so with the help of the thermal analysis students, we are going to explain the, if you know the properties of thermal analysis, then only you comes to explain the properties of alloys. Now here students, if the freezing points are plotted against the composition of alloys obtained by adding successive quantity of one metal to other. Now students, here if you are going to draw the freezing points are plotted against the composition of alloys obtained by adding successive quantities of one metal to the other metal. One can get the freezing point diagram. Then you are getting freezing point diagram. Now here students, for zinc and cadmium alloys, here it has been given. The line X and Y shows freezing point curve of zinc when small quantities of cadmium metal are successively added. So students, with that we are going to see the freezing point diagram for zinc and cadmium. Okay students, now students, when zinc and cadmium, when you add students, see the temperature students, this is the temperature versus composition diagram is given students. So here students, when you are taking 100% zinc and you are go on adding and it will become 0%. Here you have taken 100% zinc students, the temperature is 321 degrees Celsius. 100% zinc is temperature 321 degrees Celsius students. When you go on adding zinc and cadmium, the composition students, when you increase the quantity of, here the quantity of zinc 100% to 0% decreases, and quantity of zinc here you are go on adding from 100% to 0 degrees Celsius. So as the quantity decreases from cadmium to 100% cadmium to 0% cadmium and 100% zinc to 0% zinc. So what happens students, what is happening in the temperature? So temperature of both the metals go on decreasing. See students, see the temperature. Now it is 419 degree, it is go on decreasing. See the temperature. Okay students, it is go on decreasing, it is also decreasing. Understanding, at 270 degrees Celsius students, both you are finding both will have same type of temperature, thermal temperature at point Y. Understanding students? So that is we wanted to show here students in this diagram in figure 1. Here students, zinc and cadmium is given students. Here zinc is 100% and cadmium is also 100%. Okay students, when you are both are, we are going to add at the time students, here zinc is present in liquid state at 419 degree and cadmium, which is 100% students, is present at 321 degrees Celsius. Okay students, what happens students, both are present in liquid state. When you are going to add slowly this cadmium and zinc, what happens students, zinc and cadmium. So students, this is the zinc students and this is what cadmium. Okay students, when they are present in liquid state students, when you are slowly if you add, they are going to go to the freezing point. They have formed the solid. See boundary, below the boundary all these are the alloys, these are the mixture of alloys. So students, you are finding the freezing point at 270 degrees Celsius. So this is the, that is called as eutectic point students, that is eutectic reaction. Understanding students? So this, they will form the solid solution. That means this is the freezing point of this alloys, that is 270 degree. Similarly students, now line YZ, here students, shows the freezing point curves of cadmium. So students, XY is the freezing point of zinc and YZ, this is the curve of cadmium along the line YZ. Okay students, pure zinc separate out, it is in equilibrium with melt, and the point Z is called eutectic point. Understanding students? So you will get point here, that is called, this point is called as eutectic point. Eutectic point, and you can also say this is a eutectic reaction is taking place. The dotted line, this is the dotted students line in the figure, indicate the boundary condition between separation of crystal of zinc and cadmium and the solidification of alloys, that is entire mass. Understanding students? So this boundary will separate the solid state of the alloys and the liquid phase of the metals. It will be seen that the freezing point of alloys are always lower. See students, it is lower, that is 270 degrees Celsius. than the component metal having higher freezing point. The component metal here, students, you have zinc and cadmium. Okay, that is why 100% zinc to what 0% zinc. Now here, students, you have taken cadmium 100% zinc, and when you go on adding, students, it will becomes what 0% zinc. Understanding, students? So this way this diagram is there, students. Now here, students, this is the second, that is magnesium and stannous. Here you, students, you have stannous, 100% stannous. So students, we are talking about the alloys of stannous, and here we are talking about magnesium. Now what happens, students? Here the stannous, they are present in liquid state, students. This is liquid state, and here they are present in solid. Okay, students, solid alloys. When you see the solid alloys, students, this is the square box. So students, this is the solid state, that is alloys. This is the phase of the alloys which are present in what solid state, and here, students, you will find two eutectic point B and D. Understanding, students? So this is the alloy of magnesium and magnesium stannous, and this is the alloys of stannous plus magnesium stannous. Understanding, students? So here the stannous will be more, here the magnesium will be more in these alloys. Understanding, students? So both are alloys present in solid states. So here you are getting two eutectic point, students. So it will be seen now here, students, that already I have explained. You are getting freezing point of alloys are always lower than the component of the metals having higher freezing point. So this is the higher freezing point. Understanding, this is the liquid state, students. When they will come here, they will form the two types of alloys. Understanding, students? Now we are going to see, students, in above case of, now when you are talking about in zinc and cadmium alloy, there is neither the compound formation. In zinc and cadmium, there is no compound is formed, neither the compound formation nor the miscibility of the component in the solid state. Many times the component metal give rise to the formation of chemical component of the definite composition. This compound will act as it is foreign substance. Hence the freezing point diagram shows the two eutectic points. Why it is forming the two eutectic points, students? Because of this, the component metals give rise to formation of chemical component. It is forming the chemical component of definite composition. This compound will act, it will interfere and foreign substances, and hence the freezing point diagram shows two eutectic points. Why the freezing point diagram shows two eutectic point, students? Because of the formation of chemical components. Example I have already explained, students. The alloy of magnesium and tin, that is stannous, is an example of this type, where compound magnesium stannous is formed, that I have already explained in figure 2, students. The formation of a compound is indicated by the hump. You are getting the hump in the freezing point diagram, while the highest point is C on the hump given the composition of the compound as shown in figure 2. In some systems, students, both components are completely soluble in liquid and solid state. The thermal equilibrium diagram of the type shown in figure 3 is obtained. So this is the 3 is, students, when they are completely soluble. So liquid is when they are, this is the phase above these, students, you will find liquid, and here they will form the solid. So that is why when they are completely soluble, students, so this type of alloys you are getting. Understanding, students? The solid solution, these are frequently melt in alloys. Example, students, here silver and gold. If you are taking silver and gold, cobalt and nickel form the solution that mix with each other in all the proportions, students. So you are getting this type of diagram. Understanding, students? Here this straight freezing point curves is showing, students, and this is the what melting point. So this is very important, students. In examination for 4 marks question, they may ask in board examination, students. So this way you have to represent the answer. This is very important, students, for the examination point of view. This way, students, you have to represent the answer. You will get the full marks. Like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.